Okay, so for question 14b, you actually have this compound here, potassium hydrogen difluoride, KHF2. So even if the question didn't give you the formula, you should be able to come up with it on your own, because potassium hydrogen difluoride, okay, with the 2, okay, it is an ionic compound containing one cation and one anion. So you are supposed to write the formula of the ions present in this compound. Well, so if you are not sure how to continue from here, you just need to think of an ionic compound that actually contains K. So you can perhaps think of KCl, and of course it is made up of K plus and Cl minus. So just based on this simple example, you extend your knowledge to that of KHF2. That means KHF2 must definitely also be made up of K plus, and the other side will be HF2 minus. So this actually gives you a correct answer. So your cation should be K plus, anion should be HF2 minus. So in this case, we actually draw this square bracket to indicate that this negative sign actually applies to the whole of the HF2. Okay, so for question part 2, they ask you to draw a structure for the anion and state what types of bonding occurs within it. So in this case, what types of bonding? Well, you can possibly think of a few things. You can have ionic bond, okay, you can have van der Waals, okay, you can have hydrogen bond, you can have metallic bond, and of course you can have covalent bond. So out of these 5, you can straight away cancel out ionic, because we know that ionic is only between positive and negative ions. But in this case, the question only has the anion, and of course it couldn't be metallic. This is very obvious. So we are just left with the options van der Waals, hydrogen bonds, or covalent bonds. So in this case, in order to know what types of bonding occurs within HF2 minus, you need to know how to draw it. So how do we draw it? Well, always break things down into things that you know and work from there. So the thinking process, okay, how you can actually work on it will be to break it down. HF2 minus. Well, break it down into something familiar. Well, you can think of HF and you can think of F minus. So in fact, this is a very similar example to what you have learned before, which is the I3 minus. Remember, we know that it is made up of I2 and I minus. And last time when we were doing the Chem Bonding visualization lab, we actually mentioned that for these I minus, okay, because it actually has 8 valence electrons, 1, 2, 3, 4, 5, 6, 7, 8. Okay, 8 because it is 7 plus 1, okay, due to the negative charge, okay, it actually contributes a lone pair, okay, for dative bond like this. So for the I2 over here, we know that it can be drawn in this manner. Okay, and for this I minus, because I have a lone pair of electron, I can actually contribute to these iodine atom through a dative bond. Okay, and this would be how your final product would look like. So I can draw I, and it's a dative bond, so I must draw an arrow pointing towards the I. 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. Okay, and please remember you need to put the overall bracket with a negative charge. So with this knowledge, okay, apply it to your HF2 minus. Okay, so let's draw HF first. HF, okay, and F will have 1, 2, 3, 4, 5, 6 valence electrons left over, and for this F minus, of course, it will have 1, 2, 3, 4, 5, 6, 7, 8 electrons, again due to 7 plus 1 is equals to 8 due to the charge. So we can do a dative bond also. So now the question is, you have to ask yourself, does it dative bond to this hydrogen atom, or does it dative bond to this F atom? Which one should it be? Well, you need to ask yourself, which atom will ultimately be the central atom? Of course, it must be hydrogen, because hydrogen is less electronegative. We know that the less electronegative atom will be the central atom. So of course, in this case, a dative bond to the hydrogen atom. Okay, so how do we draw this hydrogen bond? Of course, very simple. If we draw out the structure again, it should actually look like this. HF, okay, with a dative bond from fluorine to hydrogen. So 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. And overall, you must remember to put a square bracket and a negative sign. But actually, this ion is drawn wrongly. What is wrong about this? Can you spot the mistake about this ion? Now take a look at your hydrogen atom. How many electrons are surrounding it? Over here you have 2 electrons. Over here you have 2 electrons. Altogether you have 4 electrons. But ask yourself whether hydrogen can take more than 2 electrons in its valence shell. Of course not, because hydrogen, okay, is in period 1. It only has 1 s. Okay, if you go on, it cannot take 2 s because 2 means second period. So 1 s can only mean it can maximally take 2 electrons. So this is definitely not possible. So if it is not possible, what do you think these dative bond can be changed to? Well, to give you a clue, this is hydrogen, and F is a very electronegative atom, the F, O and N. So I guess that you might have gotten it correct. You must change it to hydrogen bond. Okay, congrats if you have gotten it correct. Okay, so to give you the correct answer, okay, you should have this as your correct answer. Okay, you can compare it with the wrong answer. Okay, this one is actually wrong. This is the correct one. So you notice, in this case, I still have my H as the central atom. Okay, and I need to draw this as a hydrogen bonding. And again, for hydrogen bonding, you need to draw the delta plus on H, delta minus on S minus, and of course over here what's missing is a delta minus. And of course draw the lone pair from the F atom. Okay, and overall, of course, you need to draw the bracket. And not forgetting, you need to have your overall minus charge. So now let's go back to the question, what types of bonding? So out of all these options, of course you have your covalent bonding, okay, because your covalent bond is this bond between the HF, and of course it must be hydrogen bond as well. Okay, so you have gotten your correct answer, covalent bond and hydrogen bond.